Okay, yeah, fingers crossed. We are on Skype and phone. Okay. Yo, bye.
It's a big day at ESTEC, the European Space Agency's Research and Technology Center on the Dutch coast. The scientists here are testing whether they can move a robotic arm via a mobile communications network. It's being controlled by a colleague 500 kilometers away. The goal is to one day be able to do the same over distances of millions of kilometers, directing robots on faraway planets from the surface of the Earth.
We actually want to bring people to Mars.
The next mission to Mars is slated for 2016. With current technology, our planetary neighbor is too far away for astronauts to make the trip, but a robot could make it easily. There are still hurdles to overcome until the mission lifts off. NASA dropped out of the project not long ago, and the ESA is now working together with the Russian space agency Roscosmos to make it happen. Since the beginning of the political crisis in Ukraine, relations have grown strained. And the Russians are supposed to supply both cash and the launch vehicle.
They are very important. Clearly, nobody is unreplaceable, but then it's like if you were two to go on a trip and sharing the cost, the other one drops out, now you share with yourself. So there's a financial impact.
The experts tinker with the Mars rover in a realistic Martian landscape set up right next door to the robotics lab. Once the vehicle is out on its own on the surface of the red planet, problems like this would be disastrous.
The wheels are too stuck in the terrain. You run into trouble.
There are still many small problems to iron out with the vehicle here on Earth, and more than a few big ones. What are the researchers looking for exactly?
The goal is to scientifically to search for traces of life. And the best place to look for traces of life is in the subsurface, in the top, let's say, meter to 2 meters underground.
But just how much will it cost to find that out? The European space researchers are constantly developing new high-tech tools. For example, this space simulator. It's for testing electronic components that one day might be used in the Mars mission. How well do the parts withstand the vacuum, radiation, and extreme temperature fluctuations in space? The project has swallowed more than €1 billion so far, more than twice its original budget.
The investment we do, it's investment in the future. And it's certainly not a major investment. We're talking about basically the equivalent of one cinema ticket for every European citizen per year. To do missions like this, to discover the first light of the universe, like in Planck.
So let's share my screen with your screen so that you can follow.
Back to the robotic arm experiment. The engineers in Darmstadt are trying to install a component from 500 kilometers away. In Noordwijk, the arm keeps missing its target because the signals telling it to move take a few seconds to arrive. Have the engineers bitten off more than they can chew? Then, finally, success. Via a wireless network, the arm has performed the assigned task.
Well, if it hadn't worked, it would have been pretty embarrassing for us. Yeah, definitely.
Now the remote control team can move on to the next stage of testing, controlling the robot using radio signals. After all, there is no cell phone reception on Mars.